in this lovely, still kind of warm afternoon in Krakow. Today we have, let me check, because I have problem in numbers and Maria is always telling me that I'm unprofessional. So 61st meeting of AWS User Group in Krakow. My name is Maciej Lelusz. I'm an AWS hero and leader of this group. Yeah, nice to see you. Today we are under the, like a support of PMI IT Hub. Those guys supporting us almost a year right now. And today we have a creme de la creme presentation. We have two sides of the, let's say, riddle. So PMI IT Hub, right? Tomasz and Σούνavο. All right, Σούνavo AWS, right? Okay. So haters gonna hate, right? But there is a vendor and there's a customer on one scene, and they will talk about solution. Oh, I cannot add it. So they will talk about the solution that they developed together. It seems very interesting. I will not steal your show, guys. The scene is yours. We have 45 minutes, short break. Don't hesitate to ask the questions during the show, okay? Yeah. So the guys want you to ask during the show, not to wait till the end.
Interrupt us as much as you want.
I want to tell something. No, just get in, and I will bring you a microphone, okay, if you want. So you will have a voice that everybody also online will hear us.
If there's anyone online wanting.
No, the online, come on. Who is online, right?
Ban them.
Ban them. No, of course we'll read your comments. We'll read your questions. So guys, don't hesitate and have fun.
Actually, what Maciek said, we are from PMI, but actually from being a customer, we've become something I think more, and we'll talk about it a bit later. So this presentation is about our co-development and co-development of Industrial IoT Platform, which we do together with AWS. I was asked to skip that part. Introduction about me. My name is Tomazz ৱołek. I'm in PMI for the last 4 years. Somebody wants to break in. That's good. And for this last 4 years, I've been assigned to a building of Industrial IoT Platform. For the last 3 years, I've started to learn cloud computing based on AWS services, and I'm IT professional for over 20 years. Besides being an industrial IoT architect in PMI, I've been performing a role of the IoT platform component owner. So I'm an internal product owner. Σούνavo.
Hello, good afternoon, everyone, and thank you for joining, people who are joining in person in spite of the heavy traffic. Thank you all for coming over here. So my name is Σούνavo. I'm a senior product solution architect in AWS, and I work for a team called AWS Industry Products. So what we do in AWS Industry Products, I'll explain shortly, but I've been in AWS for about now 3 years. And before that, I used to work for Philips Healthcare as an IoT platform architect for that consumer IoT platform. So I'm based in Netherlands, Eindhoven, more south of Netherlands. I flew all the way from Eindhoven just to talk to you guys. And what do I like to talk about? Apart from the great weather in Netherlands, it's about IoT and manufacturing. That's my passion. So I feel very lucky that I can follow my passion in AWS. So if you have any questions around IoT, manufacturing in general, connecting devices with software, that's my area. That's what I like to talk about. Look me up in LinkedIn. I have a fairly unique name, so it should be easy to find me on LinkedIn. I'm happy to connect and talk about it.
Most of you probably know his company, and you probably have heard of Philip Morris International. But what I wanted to say, and I wanted to explain you the size of our core business, because beside having an IT hub here in Krakow and hiring IT professionals, we have factories. We have like over 39 of them. They are displaced around the globe. So we have factories on all continents beside Australia. And we can actually divide them into two types of factories. One first type, which is related to the conventional products. So you probably know about cigarettes, tobacco used for pipes and so on. And the new type of products, which is called reduced risk product. Most of you heard about IQOS. It's quite heavily advertised. But this size of the enterprise and this size of the core business you can imagine that the IT portfolio is also significant. I've put some numbers over here. I mean, it's really rough numbers. As far as I remember, it was like 1,200 different IT systems supporting manufacturing only, including quality, supply chain, and other stuff. It's really huge landscape, which we are trying to transform. Regarding what's on the factory floor, the first number is interesting because it says it's 14 primary substrates and 1,600 secondary consumables. What is the difference between primary and secondary? We divide the factory and manufacturing process into two parts. The first part, which is called primary, which is from tobacco leaves to what's fitted inside the tobacco sticks. So either cigarettes on this or just heats, for example, which is like usually big lines with continuous production. Processing the tobacco, cutting, adding some flavors, and so on. And the secondary, which is making the tobacco sticks, packing, and then putting them in a bigger containers, preparing to be shipped. So that's PMI manufacturing.
So I mentioned that I work for a team called AWS Industry Products, which is a kind of a product development org in AWS, but it's fairly new org. So what do we do there? So we are kind of different from other AWS product orgs in the sense that we are hyper focused on one of the Amazon's leadership principle, a key one, that is customer obsession. So what we do is that we work with industry leaders, in this case like PMI, and we try to build products that will deliver immediate business outcomes for them, that will deliver kind of the most important business outcomes for them. But having said that, AWS building custom software is not really our bread and butter. So you all know AWS for building like different kind of services. So what we try to do during this process is to figure out if there are products and solutions in that what we are building for PMI that we can cater to the larger industry market. So the intention of doing this is that we work with an industry leader, we understand what are the requirements for industry, and we try to build a product that caters for the industry. That is not the typical Lego blocks that you see, but it's more a product that can be transformative for the entire industry. And how do we do that? The way we do that is that we categorize the service into different levels. So AWS focuses on the foundation services and PMI focuses on the business integration part. And then we work together to build that product. And once that is mature state, basically we see is there a potential service in it. And that's how we try to learn from the industry and build products that are catering for the industry. Currently, we are focusing on this 7 domains. Some of them are more mature than others. So automotive and manufacturing, can keep the previous slide. Yeah. So automotive and manufacturing is probably more mature. The other ones, we are working with different kind of industry leaders to start up this co-development process. If you are wondering about a couple of acronyms there, HCLS is healthcare and life sciences. METS is media, entertainment, telco, and sports. It's more related to streaming and broadcasting kind of use cases. So yeah, if you could go to the next slide. So let me explain a little bit how the co-dev process works. So we start with scoping the solution. So we start like, what is the scope of the solution? We look at what is the repetitive solution that can create immediate business value. And this is around, let's say, around 4 to 6 months process. And the outcome of the process is that we have defined the scope. We have defined kind of tangible AWS outcomes. And we have defined some kind of repeatable solutions that can cater to wider industry market. Once we do that, the contract is signed. And basically, the co-dev starts. And we start developing the software in a customer-obsessed way, meaning that we try to see what is the thing that will bring immediate business value to PMI. And we start working on that part of the software. And then when the software, we make releases on the software, and when it is when it is in a mature state, we move the software to what we call like a private production environment. So the software is live, but is live on a PMI environment. It's not globally available. So when you see the proof the business value with PMI, that this software that we have built, this service that we have built serves the leader that we are working with, we take it to the next level. So we try to see what are there gaps to make this as GA service or, as you know, generally available service. And then we try to fill up those gaps. and make the service generally available like any other service, EC2s, S3 that you see, right? So that we make the service generally as well. And then it's business as usual, right? So then the workflow is the same as we go to customers, try to understand the business problem, and see if this particular product is a good suit for them. So that's how the product development works. The idea is to build these products that are transformative for the industry. Apart from the product development, I would also mention it's a very unique way of working with two teams working together. So you have the PMI development team, you have the AWS development team. They have full visibility on how each other are working, how we develop product, and we have full visibility on taking up products to the end customer at very early phase. Instead of before the GA phase, at every iteration, we can test the products. Let's say with the factory floor engineers, with the OT engineers, we can test the product and have those feedback flowing into the machine. So we've got to work in a very collaborative way. The engineers work, engineers, solution architects. So everybody has a counterpart in both teams. So like Tommatzz is the solution architect from PMI side. I'm the solution architect for the project. From AWS side, we have similar for product owners, for delivery managers. We have our counterparts in both teams. And although teams are geographically distributed, they often meet up in common locations. Just like 2 weeks, 3 weeks back, we had a workshop and we work together. Everybody comes to know each other, way of working.
Sorry, can I have a question?
Yeah, sure. Please.
How many people?
How many people in
the whole project? People in both teams you have? So
what we work in Amazon is what we call two pizza team. So two pizza teams generally don't have a fixed number, but you can say it like a team that can be fit by one pizza. And of course, depends upon what kind of pizza, American pizza or European pizza. But let's say around 8 to 10 people around a team. And we have one team in US, one team in Europe from AWS side. And
from the PMI side, I think it's more than 20 people now, because it's not only IT people who are involved, but also our business side, right? So they are like actually, for both of us, they are our customers. So we are like split. I mean, we are not split. I mean, in theory, we're logically split as IT team, but we work together, and they are our customers. But I mean, to be honest, for me, it was like first time in my life when I see really a product team forming like according to the book, let's say it so. So it's really...
So you work in waterfall, right?
No, come on.
Come on, I'm just kidding. Any questions? Just, I'm trying to encourage you guys. They are here only for 1 hour and 15 minutes, so ask the questions.
Maybe we can tackle the ways of working a bit later on, maybe closer to the end of the presentation, because it's a topic of itself. So if you have any questions about how we work, I mean, I can share my point of view, which is like it was a groundbreaking experience for me to see how agile can you be with a specific, very simple tools, a really light approach, and how you can bring the innovation in a really extremely fast way, comparing to the old ways and sometimes pretending to be agile just by using Jira and Confluence, which, I mean, it's not doing anything. All right, so maybe we can start.
I think that's the main part. Like both teams learn from each other. We learn the industry experience from PMI. PMI learns. We have learned a thing or two about developing software. So I hope PMI is able to learn from that. So that's how we benefit. It's not just about the end product that we are going to release, but also about the way of working.
What's important to say, because I'm not sure if I mentioned this, internally in PMI we have a software engineering team. So actually not people who are able to roll out existing solutions like open source, just starting containers, managing Kubernetes, whatever. We also have people who can actually develop something, write a code. Our department is based in Portugal, and actually they are part of this co-development team. Let's talk about Revolution.
Yeah, let's before we go into the product, what we are building, let's talk a little bit about the Industry 4.0. So unless you have been living under a rock, you have heard of Industry 4.0, right? So how did it start? So the interesting thing is that the word manufacturing comes from two Latin words called manus and factus, which basically means handmade. So manufacturing used to be entirely handmade thing until the 17th century. So when basically the steam engine, the boring machine, the spinning wheel, spinning jenny, all these inventions came about that triggered the first industrial revolution. And then around 19th century, it was the steam and electricity, those powered the second industrial revolution. And when you think of the Industry 2.0, it was about building mass productions, about producing a lot of things at the same time. And some of the key pioneers was Ford in 1913. He invented the idea of factory and producing in mass scale, which made automobiles available to large population of US. Although Ford is credited kind of with the idea of mass productions, there was an interesting anecdote I want to share with you. So there was this gentleman called Eli Whitney. Eli Whitney was an inventor and a manufacturer in the US, and he got a contract to manufacture 10,000 musket guns for the US government. At that point of time, gun manufacturing used to be a very handcrafted way. So every craftsman would build the whole gun in a completely handcrafted way, and every gun would be different from each other. If it malfunctions, you cannot simply take out a part and replace it. And what he did was he trained his team to produce a certain part of the gun, not the entire gun. And he took all these parts and he asked an audience with the US government, including then President Thomas Jefferson, and he laid this out on a table. And he asked the audience to pick up any of the parts randomly, and he was able to assemble a gun together. Today, if you think of it, it doesn't sound that groundbreaking, but at that point, it was really transformative. And the whole seed of discrete manufacturing was in that day, right? So when he was able to do this kind of assembly process. And this kind of triggered one thing led to another, and this kind of triggered the whole industry 2.0 and the mass production idea. And then late 19th century saw the emergence of electricity, microprocessor advancement and electricity, which kind of triggered the third industrial revolution. The fourth industrial revolution is happening now as we speak. And there are many opinions on like what's triggering this. Some say it's AI/ML, some say industrial IoT, some say it's cloud computing. I think it's all of this together. But the key force behind this is data. Making data available to the right person at the right time and with the right context. And that's what's basically the fundamental idea of Industry 4.0.
I think that's also one of the goals, is that you want to make the human beings be productive in a different area. As the story started with the manual work, people assembling things, then we could automatize a bit with the steam, then with electricity, with the introduction of the PLCs. At the end, you actually don't want people to touch the machine. You actually want to people invent things, how to optimize the machine works, to get insight on another creative level. So to use the human brain fully, I mean, as a creative entity, not like as an operator and switching on and off or pressing a switch. I mean, human beings can do better. And I think this is the enabler. So to how to move forward. Of course, there is probably, it is, as all revolutions, there are some challenges. So there will be less people in the factories, probably. I mean, it's happening already now. We are aware of a couple cases in Europe where there are lights of factories, which are completely empty, completely dark. There is just input of materials, and there is just output of the product. Of course, it's simplification. There are some people who need to still maintain it, but we are really close to that. And I think it's really something happening during our generation. It will be there. It will be probably not possible to transform all manufacturing to that mode, but there will be more and more, and it will come in the future. Yeah, and this so-called digital transformation is really catchy words for the last couple of years. It's coming across all the industries, and consumer packaged goods, it's one of them. So the PMI area. You can imagine we also had some use cases in agriculture, because actually we are using plants to make our product. So I'm aware of some experiments with IoT applications for farmers to you can imagine, get the weather conditions, get the temperature, get the rain amount, and so on and so forth. Mining is quite a heavy industry, and it's quite dangerous and risky. So probably you want to remove people and also replace them with kind of different equipment. Transportation logistics, it's easy to imagine that you can put GPS tracker on almost everything and then try to optimize the way it works, the way it goes, and so on. Oil and gas industry, quite also heavy industry. I know couple cases of this. There are quite specific ones, because I mean, you can imagine like you have an oil mining platform which is in the middle of the sea. You just cannot stream everything up to cloud and then just to process it. So there are really interesting cases out there. And power utilities and renewables. That's really catchy topic because we are transforming and going to the sustainability area. It's a really important one.
Sorry, there is one question from the void.
Void.
Yeah. So the question is from Carla, and wait a second. Oh, well, all right. So would you like how you can explain difference between Industry 4.0 and IoT?
Oh, we have a whole slide for that. It's just coming, maybe.
Yeah. All right. So let's wait. Let's wait, guys. Thank you.
There will be an answer. Yeah.
Yeah, so what Tommasz says, there's all these use cases that you heard, they are all accelerating. But what I have seen working with manufacturing, I've been working with manufacturing customers for a while now, is that what happened, all the incidents of 2020, 21, the pandemic, kind of had a strange influence on manufacturing. On one hand, it was a struggling time for them because the whole supply chain was broken and they didn't know how much to produce and what well. It's unprecedented event, right? So something that they were not prepared for. But at the same time, manufacturers realize that they have to invest more on this kind of use cases. They have to invest more on understanding the data, having this data connected together. So suddenly we see a huge thrust towards Industry 4.0. It kind of vaulted the industry 5 years forward, what those 2 years of incident. And we see that. That's why we see a lot of manufacturers who have been working with this already. We see some great numbers from them in terms of reduced downtime, reduction of defects, introducing new products, OE improvement, improved inventory, reduction of inertia. All these are great numbers, but I still think we have barely scratched the surface on this.
I can only confirm what you are seeing here on this. All these values have been confirmed on our side, and this is really interesting one, which you can actually, when you think about it, I don't know how many of you are tobacco users, but I mean, Marlboros, they existed for 50 years. They were basically the same. Now, each 1 year, you have a different kind of heats or different kind of product which we release, and it's accelerating. So this is one of the really big enablers for us as a company. Reduction in defects, reduced downtime. It's really important, necessary. We'll talk about it in next slides. The OE improvement and reduction in energy use. All these values that PMI is looking also for. Yeah, there are some manufacturing industry trends which are really necessary to identify. I mean, the first one which we already talked is that data is an enabler, is a part of Industry 4.0. And we want to have the manufacturing digitally executed. As I said before, we don't want people to operate the machines manually, so to turn on off some switches, because it's just not bringing much value. Product as a service, we are going towards that concept. I mean, we have an idea that the devices which are heating tobacco, but we are not smoking tobacco, we are heating tobacco, we want to serve them as a service. Connected products is the same concept. I mean, also we want to connect and get the data insights coming from those. And sustainability, you want to be as effective as possible. Use cases, smart factory use cases, yeah. There are different ones, and we divided them into a couple categories. The one which is probably most obvious is about the product and process optimization. When we want to have optimize the waste and reduce the loss. Computer vision for quality control. Basically, if you think that somebody can check each one product for quality measures, I mean, it's easy to imagine that you can get a lot of benefits over here. Predictive and preventive maintenance for machines. So you want to replace the part of a machine before it breaks, not after it breaks. Because if you can plan it up front, it's not a surprise for you, and you save some time. Machine as a service, already have some cases like this. We are looking at this concept. So instead of buying a machine, we hire it, although it is still connected to our ecosystem. Digital twin is like a simulation or like a digital ghost of the machine. which can give you a space for experimenting on changes and of settings of the production. Automated material management. We have first time when I was in our factory in Bologna a couple years ago, I was amazed with a picture which I've seen. It was like 50 AGVs on a one corridor in the factory. The corridor, just to give you a hint, is like almost 1 kilometer long. So it was really amazing to see it. And we have a couple more factories which are also introducing AGVs. Track and trace. Our company is obliged by legal reasons to do this activity, so to track our products. It's European Union regulation. Some of the Middle Eastern countries also require this part. And OEE visualization, we'll talk about OEE in a second, what does it mean? It's that we need to visualize the efficiency of the production process.
Right, so we have, Tómazz shows a bunch of use cases there, and we'll focus on 3 of them, because if we talk about all the use cases, it will take the entire day. Anyone from a manufacturing background here? Yeah? So you guys know what OEE is, right? Because you cannot be in manufacturing without knowing what OEE is. It's such a fundamental thing of manufacturing. So OEE, for the rest, basically OEE means overall equipment effectiveness. So what does it mean? It's kind of a report card for your factory. So it says it's a percentage, basically what the factory is actually producing versus what theoretically it can produce. And it's not a new concept. This concept, there were articles dating back a decade more, even 2 decades back, that talk about OEE. And if you look, and if you look back, say OEE, there are articles like 2 decades back which talk about OEE, and even Lean, Six Sigma, these are all, they have talk about OEE. So it's not fundamentally new. But why is there a renewed discussion about OEE, especially in context of Industry 4.0? We'll come to that. But let's first understand what it means. So I said OEE is basically what the factory is actually producing versus theoretically what it can produce. So why is not the factory producing always at the topmost level? Because realistically, when you are in a factory, things break, there are stops, there are switchovers, the brand changes, a lot of practical things happen, which prevents the machines from always going full steam at one go. But if you look at all those reasons that why stops happen or why you are not producing at full factory, they can be broadly categorized into 3 things: availability, quality, and performance. They are always under these 3 buckets. So what you do is basically OEE is a measure of these 3. So it just calculates a percentage based on your availability, quality, and percentage. And then it calculates the OEE. And that's basically a measure of how your factory is doing. Now, why are we talking about it now? If this is not a new concept, if this was there 2 decades back, why are we talking about now? For that, you need to understand actually how OEE is calculated. So what happens to calculate these values? There are 4 variables that goes in: infit, outfit, waste, and status. Infit is the number of widgets that are going into a machine. Output is the number of widgets coming out of the machine. Waste is the number of widgets that doesn't pass the quality check. And status is the status of the machine at a given point of time. So all these variables are fed into a MES system or machine execution system. And that calculates the AQP, availability, quality, and performance. And then the OEE, and that is actually displayed on a dashboard. The operator can look at the dashboard and he can know that, okay, I'm doing 85% OEE, so I'm fairly okay, or I'm doing 50%, so something needs to change, right? Now let's think about what actually happens. So let's say in a production floor, the availability is good, the quality is good, but the performance is, let's say, 50%. So it brings down the OEE 50%. The operator looks at the OEE figure, he needs to improve. So what does he do? He goes to his SCADA systems and turns up the speed of his machine so that you can basically produce more faster and bolster your performance. But what happens when you do that is that you are producing more waste. So the quality numbers come down. So how do you optimize this? Does the operator know like what should be my optimal? Should I go full-fledged and produce at the highest speed, or I should reduce the speed and try to produce more quality? The answer for that lies in basically what is the cost of your waste. How much does waste cost? And that depends upon what you are producing at that point of time. And can the operator make that decision? In a way it can, because the operator, how it works now is makes his decision from his instinct, from his experience with working on the factory floor, but that is not always based on data. And this is where Industry 4.0 comes in. This is where Industrial IoT comes in. Because what it can give you, it can make those decisions. And because after a certain point of time, I mean, you think you are gaining efficiency with OEE, but eventually operator is not the right person to make that call. So what Industrial IoT gives you, that it can capture this data, put it on analytics systems, use machine learning, move those inferences back into the factory floor so that they can be accessed at very low latency and even in a disconnected environment. And then you make the right choice based on the data so that you can optimize your OE. And that is why we see Industrial IoTs. There is a renewed discussion about OE and OE dashboard, and it's such a core part of the whole Industrial IoT adoption.
When I remember my beginnings with the IoT journey 3 years ago, one of the first use cases which we had was the case related to the waste reduction. You may wonder why you want to reduce the waste of, in case of PMI. It's quite simple, because the product which we are using, the semi-products, is extremely expensive. Tobacco is an expensive material. So for us, the losses are really something that we are closely looking at. It's related to the unplanned stops, which we are also talking before, that there is a period of time after the moment you stop the machine, either as a planned or unplanned stop. There's a ramp-up period, so a moment when the machine gets up to speed, and exactly there is a threshold, and after this threshold, the machine only produces a product with a proper quality. Before that, everything is a waste. So what we want to achieve is to have as least unplanned stops as possible. And concepts like predictive maintenance, predictive quality are extremely important to us, because we want to plan the stop to make it as long as necessary, and then to have as long run as possible, probably for the whole batch. This is something that, it's still ongoing. It's not that simple, although it sounds. And IoT is one of the a major enablers for this. So let's talk about predictive maintenance.
Thomas just mentioned our predictive maintenance, and what we see along with OE.
Sorry, guys. Can I get a question for the slide that was?
Mm-hmm.
Why there are 5 stars and 85%? I'm not so good in mathematics, but
so basically
63 it's not 85. I know that it's agile, but still.
No. So what it says that this is the actual value. So if you have these values, if you multiply, it comes to 624,600 something, divide by 1,000, so it comes to 63%. So this factory is producing OE of 63%. 85% is considered kind of world-class production level.
Okay, so this is something like everybody want to achieve. So everybody want to be 5 stars.
Again, to be honest, very few do that, and it really depends upon the product to product. It varies a lot, but it is kind of, say, if you are 85%, you kind of a world-class manufacturing facility.
Cool. Thank you very much.
From my experience. Go.
Yes. Related to the 3 parameters that goes as the input for calculating OEE. So I see that availability and quality, okay, we can measure with the time and the waste and the success ratio. But how exactly are we giving the input of performance? So maybe it's a lame question for other people from
not
manufacturing, really. But for me,
it all basically comes from those 4 factors: in-feed, out-feed, waste, and status. So performance is basically the machine is uptime. So how long the machine was up.
So that goes to availability, right?
It kind of calculates this. There is a calculation, or all 4 this are fed in, and it calculates the availability. And performance is basically also the number of widgets being produced per second, per minute. So number of widgets basically flowing through the chain.
There is also speed factor, right?
The speed factor, yeah.
Right. So you can start the machine. It will work. I don't know, 500 pieces a minute. But it doesn't mean that it's performing like on 100 of its capacity, because the machine can produce, I don't know.
So that's sort of efficiency.
Sorry?
So that sort of efficiency.
Sort of
efficiency.
This is efficiency.
You produce 1 cigarette every day. That's a great cigarette. It's 100% quality, and its machine is available. It's working to produce 1 day. But if you produce 1 cigarette per day, that is not considered efficient production. Yeah, that's performance, right?
Okay. Thank you.
Thanks for the question.
Anyone else? Yeah, so the next other use case we wanted to discuss, this is also a lot of manufacturers are looking into it, and quite sought after use case is predictive maintenance or asset condition monitoring, whatever you call it. The idea is that manufacturers have machines and machines fail. Well, not all the time, but sometimes they do. And what causes fails? Like many factors, displacement, lubricant, lacking lubricant, or like there's wear and tear, all these kind of things makes machines fail. But if you look at industrial machines, they don't just fail overnight. They show signals. They show certain anomalies that can be detected. And there is some statistics that says in last 3 years, 82% of the manufacturing company faced some sort of downtime, and which caused medium to severe impact on their production lines. Now, how do manufacturers deal with this? Traditionally, they dealt into something called a reactive maintenance, which is as simple as fix it when it's broken. So when the machine breaks, go and fix it and start the line again. But as you can imagine, that causes a lot of downtime and cost to the manufacturer. So kind of evolved into something more like a scheduled maintenance. So you have a calendar, divide it as a certain scheduled maintenance, and at that point of time, the maintenance happens on the machine. But that also has a couple of problems. One is that you can end up with too many maintenance cycles, which means increased cost. Or what can happen is that something happens in between those cycles. How do you do that? Therein comes the idea of predictive maintenance. Again, the idea was not new. This has been here, but it was kind of difficult to implement before. And with predictive maintenance, you are trying to understand the machine and detect the anomalies. And once you detect the anomalies, you can do few things. The first and simplest thing is that inform an operator. Something is not right in the machine, go and check. So the operator goes and check, okay, the lubricant is low, pour something, or the friction is high, then maybe replace some part, it does something. But you can take it a notch higher. You can actually learn from the machine and tell the operator like what is probably going wrong. You can tell that possibly this looks like a friction issue, so maybe something is wrong with the bearings and you need to replace that. So our idea is with predictive maintenance, you predict the remaining lifetime of the machine. So when the machine is going to fail, so that you can basically schedule your maintenance accordingly. It's not a calendar schedule, but a fixed schedule, but you know that this machine is going to fail after 2 weeks. Let me schedule a maintenance after 1 week so that the issue can be fixed. And again, why was it very difficult to implement for it? Because among other things, you need to have the right kind of sensors. You need to import all the data, make the data available. And most primarily, you need to have some kind of machine learning that can understand that data and build that inference, which was not easy because manufacturing teams traditionally, I mean, PMI is big, they can afford it, but not all manufacturers have like full-fledged data science team who can understand the data and who can build this kind of inferences. But now these kind of things are becoming much more ubiquitous. There are solutions like SageMaker Canvas, look out for equipment. These solutions have built-in models, so you don't have to spend a huge amount of investment in building those models and having those data science engineers. You can use these solutions out of the box because they have comes in the built-in startup model, and you can always improve those models. But it has a startup model which you can readily utilize and start doing predictive maintenance on those equipments. So that bar for getting into a AI ML bar has become much more easier now and much more ubiquitous and available.
We have a question. Can we get a mic?
So I do have one question about. So my question is, do you also monitor the sensors? So, for example, if the sensors are getting the right reads, because I can imagine that there would be an issue, for example, when the sensor is telling you all the time that the machine is broken every 2 weeks, for example, and the machine is working fine.
Check if the sensor needs, for example, calibration, right?
Yeah, something like that.
Yes.
Want to take it?
I can take it because I wanted to back up Sounaভo that we are looking also at a case some time ago, which is about vibration sensors put on electric motors. So smart people in the factory, they realize that the electric motor, before it breaks, it starts to vibrate in a specific way. But I mean, it's hard to convince people to stay all day long and keep their hand on the electric motor on all production lines. But so there was an idea to put a couple actually of them, of the vibration sensors, and then to hire a big big data architects team to actually build some model which will be able to actually act and send alerts that, listen, this electric motor, you can imagine that in our machines, I didn't tell you that, which are sometimes a couple 100 meters long, there are like hundreds of electric motors inside. So in that specific electric motor, there is something wrong, and it will break probably in a couple hours. I think it's good enough. It's not that far that you can exactly say what needs to be done, but at least the alert that you need to plan a maintenance window and check, replace the bearings or replace the motor. I mean, it was already good enough for us because it prevented from having unplanned stop. So I told you it's the bad thing for us.
Yeah, and to add to that, sensors are very lightweight, so it's not always easy to have that kind of visibility on the sensors because they come with a very specific purpose with the microsystems. But you can basically decipher and work backwards from the results that you are getting on the analytics that something looks wrong on the machine. Somebody goes and check, okay, it was not the machine but the sensor, things like that. But to your point, like it's not very simple to actually monitor a sensor because it's very lightweight and it's probably has a couple of.
I actually remember one case because the sensors also sometimes produce anomalies. So you get the readings which are extremely high or extremely low. And you are able to say that there is something wrong with the sensor if you have too many of them. And I know that we've been able to implement some like a predictive mechanism to check that the sensor is getting you too much anomalies, and you probably need to calibrate it or check if it's working and if it's okay.
Right.
So I've been telling you about the quality of the product, and it's really important to understand that for us, it's really important because we filed a claim to FDA. It's not secret, it's official. FDA is a Food Drug Administration. It's a really important government organization in the United States, which confirmed that the new products which we produce are less risky. But they said that, okay, you can claim that fact, but you need to keep the quality as you declare it. There's another.
There is a question from from the internet, guys. Carla again. Carla again. So how do you predict maintenance for a machine that contains different failure modes that may happen in a different time? How do you define the optimal maintenance time and duration?
Yeah, I can take that. So define some of the solution that you are building. To give you an example, one of the solutions that Amazon has recent last reinvent, or was it before that? So it's Amazon Monitron. Anyone had heard of Amazon Monitron? No. So Monitron is actually a hardware device. So it has a kind of a gateway and a sensors, and you can mount that sensors on top of a machine. And it basically transmits that information to the gateway and up to the cloud. And there it comes with the starter machine learning model. So when you mount that model, you leave it for a week, and it learns from that behavior of the machine. So how much it vibrates. So for now, it just takes two things, temperature and vibration. And if you mount it on a motor, for example, it will know that the temperature around this motor is 40 degrees centigrade and vibration is this much. And when it sees like anomalous behavior to that, it can detect that. So I think, can you repeat the question if I'm answering correctly?
Yeah, sure. So again, wait a second. How do you predict maintenance for a machine that contains different failure modes that may happen in a different time?
Yeah, right. So that failure modes are detected from the historical data. So the machine learning is all about learning from experience, right? So we have put those devices in hundreds of machines, and we have learned from that experience. So we know that what are the different reasons, maybe because of lack of lubricant, lack of friction. So all these are the main reasons why machines fail. And how accurate your data is, or how accurate your prediction is that how well you have trained the model. The more and more machine models that it has trained, more when data is available, the better it gets at predicting different kind of failure modes. If you have a very small subset of the data where there was no failure, the likelihood that it will detect a strong different failure mode is low. But when the database increases or the data size increases, then it will perform better.
There is the second part of it. How do you define optimal maintenance time and duration?
How do you define optimal maintenance time?
Maintenance time.
The whole idea of predictive maintenance that you don't, right? You don't define optimal maintenance time. You do it when based on the feedback. And that's primarily the difference between scheduled maintenance and predictive maintenance. Scheduled maintenance, you define time intervals. depending on the production machine, how old are that, you define the time intervals. With predictive maintenance, you don't define the schedule. The system tells you the machine may fail in X amount of time, right? Not exactly, but roundabout, it will tell you that it will fail there. And that gives you the feedback to define when the schedule should happen. So it's not a fixed calendar schedule, but it will tell you, the system itself should tell you back like when the maintenance should happen.
Thank you. Any questions here? Okay, wait a second.
Go.
Yeah, you can go for a question.
Yeah, thank you. I assume that you do not manufacture sensors. And which manufacturers do you apply on your industry?
That part I cannot reveal. We have couple ones which provide us the sensors.
Yes, and on top of that, you collect all data and you build your own data warehouse and analyze this data with your own custom solution.
It's far shot, but yes, yeah.
Yes, but well-known industrial automation manufacturers already produce solutions for assets control and predictive maintenance and so on. So why don't you use existing solutions?
Do you know the manufacturers of the sensors who made it for our specific industry or the specific machines?
But you have typical problems with rotating equipment, with some reciprocating equipment. And I know that Honeywell produces a lot of sensors, yes, and a lot of different systems, including your application. And not only Honeywell, maybe, yeah, Siemens, maybe General Motors.
Yeah, but first of all, we don't want to vendor lock. Second of all, we can use different portfolios for different type of applications, and we don't want to buy. I don't know if you have, like, taking your example, Honeywell for this purpose, Siemens for that purpose, to buy two different solutions to make it work, right? Because it will be cost ineffective completely, because I would need to buy an IoT platform from Siemens to work with the Siemens sensors. I would need to buy a Rockwell platform to work with Rockwell sensors. Actually, I want to build one and still use to Siemens, Rockwell, whatever manufacturer, OEM X sensors, and send it to my data warehouse and using my machine learning models, not to hand it over to the vendor. I mean, it all depends on, I think, to answer your question, it all depends on the size of your enterprise, right? If you are a company which cannot afford building its own solutions because of the size, probably it's better to go towards one OEM of the sensors, the IT solution which works with it. Just go with it. For us, it didn't really make much sense because we needed different ones for a different purpose. I'm not OT person. I know that my colleagues did their job, and they decided that they cannot limit themselves only to one provider of this type of things. That's why we didn't purchase it with the whole suite, let's call it so.
And if I may quickly add to something to that, I think that's a very good question, because asset management as a market is saturated. There are a lot of players in asset management who are doing this. So it's not the core focus of our project that we'll come to that, what we are building. But we just put it here as these are one of the main criteria that are driving Industry 4.0, not necessarily that's the focus area of AWS PMI CoDev. Yeah, so that's what I wanted to show. It's not the core focus area, but yeah, it's a saturated market, like you mentioned, Honeywell and many other solutions are there. But installing a solution just for asset management may be an overkill. What we want to do is a bit more than just asset management, and asset management probably will be one of the byproducts of that solution. But the goal that we are targeting is much more broader than asset management.
Okay, thank you.
There was another one.
Sure, yeah. I will add, in the meantime, some. So also there is a thing, right? So when you have a small factory and somebody buy you, it's easy to integrate the new factory, which have completely different landscape of products when you have your own solution.
So different companies will have different sensors. So is AWS planning to introduce their own sensor systems, like they started with Monitron? So are there plans to introduce more sensor systems?
My guess is as good as yours. So I don't have visibility into the full roadmap. What AWS works as like a very distributed system. So I don't have visibility on every product that's going on. And neither if I had even, I would be able to share that. But the way we work is that whatever customers ask, 95% of our things that we build is basically what customers are asking us. So if the customer says, this is a big problem for us, you need to solve for this. Yes, of course, why not? We will try to do this. Is it our core specialty? No, probably we'll work with some partners to build something like that. But it all depends how many customers are asking for it.
Okay.
I think there will be more answers coming in upcoming slides related to the data architecture and data frameworks, which are kind of abstraction layer for the data coming from the sensors. So we'll answer that in probably a couple slides.
Yeah. So you said that you cannot talk about from where are the sensors, yes?
No, actually, I don't feel empowered enough to reveal what actually are our vendors.
Okay, because I wanted to ask about which companies you cannot talk. That would be simpler.
No. Smart move, but I will relieve them from this question. They will come back to you on the break. Okay, I understand the point. So, do we do a break right now, or
we have one more slide which I started?
Okay,
and I didn't finish.
The question here, right? Wait, no. Yeah, of course, it's going to be deleted. So, questions here? Questions on the internet? Nobody. Okay, let's go, guys.
So this will be I promise this will be the last slide about why and the business background. Then we'll go to the more technology related topics. So one of the type of cases which we are talking about is related to predictive quality. Just wanted to show you that for us it was really important to introduce it, because we need to, as I said, to keep the quality at the stable level as we declare it. And that's why, and as you can imagine, our machines can produce up to 10,000 pieces of something per minute, which is like really, really fast. A human eye cannot catch the non-conformities or faults in the product. That's why you attach a camera, high-speed camera, you put a small device next to it with some machine learning model, and then you can detect the faults. Of course, before you need to learn the model, and you could detect the faults. And as a next step, you can even control the machine to prevent of, instead of having 1,000 sticks made with the non-conformity, you have only a couple ones, because the machine learning model can, turn the settings a bit to the right or to the left to not to lose like 10,000 sticks. And that was actually the last slide. I think that are there any questions related to this? I think it was quite.
It's not the last slide, but it's just before the break, so we have a few more.
About last slide about why.
Oh, I see you.
No, I cannot.
Okay, all right, let's go for it.
Really.
I'm curious right now.
Is it another sensor question?
Yeah, just
sensor question.
Yeah, this is a serious one. I wanted to ask, what do you use to gather all of these images and then learn? Like, do you use on-prem servers, or do you use, I don't know, S3 or something other? If that's something you know and you can share.
We do both. We do both, actually. Why? Because if the images are really high quality and they come in a big amounts, we try to store some of them locally. For longer archiving process, we move them to S3. So it's like we try to be smart and cost effective here.
So one thing I would like to mention is that this is the first time we are talking about a product that is being developed. It's not a common thing to do in AWS. And for AIP, the AIP manufacturing, at least I can say, this is the first time we're doing it. So you guys are like the privileged one who are hearing about this. So when this product ever becomes GA, remember that you were the first ones to know about it. But it's not a standard practice that we talk about products even before they're released. So.
When I said that we are doing it, because our journey with the IoT platform is of 4 years. We joined powers with AWS like 1 year ago, and the development has started a couple months ago. So we have our journey from before. I'm talking now about my experience from before we started the co-development, just to be clear.
So we'll come a little bit and satisfy you.
Can I have a last question then? Yeah. Last question before the break.
Yeah, just to finish off the answer within. So we'll try to satisfy your curiosity on the last side, bit on the architecture. But as you can imagine, we are developing a service. Architecture is evolving. so we cannot go too much into the details of how exactly we are developing.
I will stop myself to these architectural slides. So, anything right now? Any questions? Yeah, let's go for a beer and short break. And after the beer and short break, or coffee or cola or whatever you want, we'll come back with the technical part, more technical part. And I think it's gonna be the like a blizzard of questions going on. So prepare yourself, and like 10 minutes. 10 minutes. It's a fast beer. So don't hesitate to do it. Like very quickly. Thank you very much. In 10 minutes we're coming back. And, I will just have just one thing. Guys, for a break, one thing. There is a QR code, and there is a pool when you can get some lovely things from Philip Morris. Yep, they are here. So ask the questions. let's see. So ask the question, reply to the questions, and you will be liable to be chosen from the group and get packs from Philip Morris. Thanks. You need some water or something?
No, I have enough water.
Do you want something from the bar?
I'll have to be at.
I understand, shaking hands, stuff like this. All good here? All good here? The questions are nice?
Yeah. How do you think it's going?
It's going very nice. It's pretty much people, it's the middle of the week, so always, it's a tough decision. From online, we have like 20 people, so it's still good, and they are from many different countries, so this is also for me, just not only Poland guys. So there is Boston guys from Boston AWS User Group, I saw them, and some guys from Latin America.
I don't know how to replace
Bon appetit. It's a veggie. If you like something more to drink,
Oh, it's okay.
yeah. Very good presentation. I think it is very good formula to have one-to-one presentation in the same time.
People are more or less engaged. They are listening, checking.
Online and also. Yeah.
Thank you. No, I have water. That's it.
Just a quick reminder. So the quiz, Maria, it was vouchers, right? So AWS vouchers. So don't don't think that there are Amazon vouchers, right? So there are AWS vouchers. So you need to learn from them or run production on top of them if you want. So some vouchers will be given for the quickest guys who make the quickest reply for all the questions there. And for most active people here, there are gonna be those 3 gifts from Philip Morris IT Hub. All right. Trudne jak zawsze. Myślałem cały wieczór. Już widzisz? Musi być szybki. Kluczem jest prędkość. Kluczem jest szybkość. Kluczem jest szybkość. O nie. Nie mogę ci powiedzieć, które znałem to zmiany. No dobra, no spoko, da się zobaczyć. Mam na to bardzo. Aż chodzi o takich rzeczach, że to trochę nieodpowiednie w ludziach z IT, bo teraz będziesz porównywał 0,01 sekundy czy 0,02. Wiesz, w końcu drogi jest jakiś faktor, nie? Z KPI chociaż, nie? Tak co tutaj okay, everybody, so let's come back and let's start a little bit because our time slot's running a little bit off the schedule. Cool. Yeah, colorful drinks, good atmosphere, perfect. Good. All good? Okay. Hey guys, I will not run your presentation. Okay, let's come back. Should I show this slide, which is set no undisclosure? Okay, this one how to not undisclosure that. Okay, we are good. You ready, guys? Ready? So let's do the second part, more techy.
The second part will be more about how.
All right.
So we've talked a lot about why and what. So now it's the part about how.
I hope people are coming back soon. So what we want to talk about. So what we want to talk about, and we'll come back to the question that the gentleman was asking, what is so differentiating that you are building, right? So that comes from the idea of like need for standards. Why do you need standards? Well, nobody ever argues that standards is not a good thing. Everybody says, yes, we need standards because it helps in interoperability, it helps in connecting systems. But the problem is this, right? So this problem with standards is there are too many of them. So you need to have one standards when it works. To show you, like if you go to the next slide. Sorry, it was the IoT one?
No, first we are going to talk about the difference between...
Sorry, my mistake. So we are going to come to standards, but I didn't
We'll come back to standards. Most of you probably heard about the concept of Internet of Things, that we want to connect everything to Internet. We have vacuum cleaners, we have fridges, air filters, temperature sensors, stuff like this. So why we have another box with the I in the front of it? What's the difference between IoT and industrial IoT?
There was a question, even someone was asking, like, what was the difference between Industry 4.0 and
yeah, what's the difference? I mean, it's the same. You basically have some sensor, you want to expose it to internet, process the data in the cloud, and voila. Actually, the size is different, and the complexity is completely different. If you imagine that air filter have like 3-4 sensors, maybe 2 actuators, the industrial machine which we are talking about, which I know, have 3,000-4,000 of them. The data gravity, the criticality of operation is completely different, because if you will open your app on your phone, you press a button, and your air filter will not stop. You just approach it, you press the button, done. What will happen if you will not have a command issued on some sensor readings on the factory floor machine? Bad things will happen. Either the company will start to lose money drastically, and there will be a lot of people who will be unhappy, or it may even endanger someone's health. So actually stopping a machine remotely, we are not there yet, because it is really for the safety reasons. But why it's not the same? Because of the data gravity, amount of data points, data security, because if somebody will breach in and, I don't know, take over your coffee machine, I mean, the worst thing can happen. You will be angry in the morning because you will not be able to make a coffee. In our case, the breach will have a serious consequences, because getting into one machine, probably, if the things are not done properly, you will take over and stop the production in the whole factory. And again, costs, a lot of people angry from the business side, and so on. I think that's...
And they are like different quality. You know, like the sensors itself, there are different quality, because I assume that, you know, when you're using something in home, you don't need to be, you know, such, you know, let's say well protected, or, you know, created on such a heavy load. You know, it's just simple stuff, right?
Yep.
And for a factory, they are different, the sensors and the IoT devices.
Yeah, so I actually come from the consumer IoT side of things. When I used to work in Philips, we built the connected vacuum cleaners, connected shavers, all those products, and then moved into more manufacturing industrial IoT. I wouldn't say one is simpler than the other in any way. It's just the challenges are different. So when you are looking at consumer IoT, there are other challenges because the device is usually moving. So you are carrying your smartware and moving to a different location, and you are connecting to different endpoints. And then there is a user aspect, right? So you have to connect your device, pair with a user, and you are using either your phone or Alexa to control the devices. So there is a kind of a pairing and trust relationship that has to be established with a user. The third most important thing that's fundamentally different is that when you have a device out there, somebody will break the device and reverse engineer and find things out. So actual IoT consumers are out there in the field. So you have to be very careful how you reduce the blast radius of those devices. Those are the typical challenges that you see with consumer IoT. With industrial IoT, it is in a secured perimeter. So there is an air gap. Tómazz will talk about the different layers of security. But fundamentally, what is big difference is the volume of data. When you are talking of machines, each machine has like 50 motors and 50 sensors, and the volume of data that is produced in industrial IoT is huge compared to, let's say, consumer IoT. Consumer IoT, okay, switch off, switch on, current status, temperature readings, this kind of thing once in a frequently. But the challenges are different, as I said. Things can be mobile, things can move around, things can be easily broken into, whereas here you have to deal with the volume and the transaction, and most important, the control back, right? So things break if you don't get this. It can have a severe impact. What Tómazz was talking about, if your vacuum cleaner breaks, okay, you will have a dirty house for a while, but it's not going to be catastrophic, right? Production, industrial IoT, if it breaks, it can be catastrophic for the production. I mean, those are the main differences that way. So in terms of like, if the sensor is different, yes, consumer IoT try for a much more cheaper form of sensors because you are always trying to reduce the cost. Industrial IoT, I wouldn't say cost is not a factor, but it isn't as much as a factor when you're building a device, because when you're building a particular device or a vacuum cleaner, you try to reduce the price of the device as much as possible to you put like the bare essential sensors there.
A question?
So may I ask a question?
Sure.
Yeah, thank you. So before Industry 4.0, it was absolutely normal to have all safety features and safety circuits hardwired, and actually there was no another possibilities. Right now we have industrial Internet of Things, and the question is, do you consider transferring and executing safety features via wireless protocols with industrial Internet of Things devices?
I can
segue to the next slide.
I can only say about I don't know why it stopped working. I can only say for our company, we don't consider wireless yet, although we are looking at it because of the criticality reasons. Maybe Ssounavo can have some other examples from other customers.
Yeah, so it is not that widespread, to be honest. So a lot of companies are experimenting that, so having connected wireless PLCs. But the fundamental reason is that most companies is this. So when you'll explain it, you'll know most companies have this Purdue model where you prevent things from this connecting back to their, which kind of the wireless does.
We can come back to this in a second after I explain what this is. This is a kind of a reference architecture which was created in 1990s, I think.
Yeah.
So it exists already for like 30 plus years. It's about creating zones of security and trust inside the factory. So industry take this as a kind of a Bible, how to stay secure and keep the wheels running. So the lowest layer is the safety critical. So this is the zone of the machine together with the process control. So this is where you keep the things really isolated from the outside world. Usually they're using the near-field bus protocols, EtherCAT, EtherBus, Modbus. There are different low latency, extremely low latency, critical protocols for the machine components to communicate between each other. It's not like really, there are no IT stuff over there. This is usually the OT world. Then we have the basic control, area supervisory control. So things when you prepare and control what machines should produce. So it's not the PLC level which controls the speed, the valves, the actuators in the machine, but it's like already IT systems which are controlling the production line. Then we have the site manufacturing operation control when you plan, for example, the short time, when you do the short time planning, site business planning, logistics network, long-term planning, what will be done, what will produce next couple months, and so on and so forth, and the enterprise network, the ERP systems, and so on and so forth. So with this separation, it's why not so many companies are getting from here directly over there when the internet is, because internet is not even depicted here. It's treated as this in enterprise network. So that's one of the reasons Wi-Fi adoption, 5G adoption, although everyone are looking at it, and it's like, yeah, we will get them, we will get there one day, but we are far from abandoning this and just jumping into the unknown. So yeah.
Now one question from our guests from internet. Let's wait a second. Okay, so sorry, two questions. Whoa. What Carolina is asking, what a typical amount of data produced by a machine per day? How often? Maybe I will split it. Okay, so first part, it's how much data it's producing. The typical.
It's extremely hard to answer. It's extremely hard.
It depends. Just use it. Just go for it.
I can give the simplest and our maybe example from our experiments, 60 megabytes a minute.
60 megabytes per minute. All right. So another part of the question is, wait a second. It's
but this can
how
be
often
this can be even 100.
Yeah, sure, of course. Yeah. How often do you gather the data points per second? Once a day, once 100 milliseconds, or it depends? That was in the question actually.
The most typical frequency I would say is one per second at this moment. Although the wish of our internal customers is to go below that, even up to 10 times per second. But that's a wish. We are not there yet.
Actually, again, just to add to that, so we always don't collect all the data all the time. It depends upon what makes more sense. And if manufacturing machine and multiple factors, right? So there are, let's say, motor speed. Motor speed is a double value in that sense, right? So it can vary from, let's say, 50.2 RPM to 50.3 RPM. That's a range. But is it information? Is something important can we do with that data? Or is it just a variable value that we need to collect? So that kind of determines like what kind of, so they have this concept called dead banding. Dead banding is basically define a range of the data change. So if the data goes beyond or above the threshold, then only try to collect the data. Otherwise, just it's a normal what you're doing. It depends upon the kind of data you are collecting. So there's no universal law like the amount of data or the frequency of the data. It just depends upon what you are measuring.
We can come back to this to answering this question when we will talk about the PCUA model, which is somehow also a way to address this, because if we have this like 3,000, 4,000 data points in the machine, maybe 20% of them there are process parameters or process-related parameters which are changing each 10 milliseconds. But maybe the rest of them, they will change once in a minute or once in an hour. So it's really hard to answer this question. If you do it in a stupid way, you just read everything and send it. It's something like this, how I mentioned. It's like 60, 100 megabytes. But it's a stupid way. We don't want to do it that way because it has a serious, you can imagine that sending all this, I mean, it won't be easy if you have a couple hundred machines in a factory. Sending all this up to cloud will be just crazy.
Okay, just say it. It depends. Yeah, right. Yeah. Cool. Thanks.
Depends a lot. Right. Any other questions?
I have a question. Maybe later you will cover that. But how you communicate between the zones? Do you communicate between the zones?
Yeah, that's in a traditional world, in a legacy world, which we still in our company at least are living in. You had systems here, everywhere. So you connected from here to here, and from here to here, and up, up, up.
So you're moving only one zone at a time, right?
Yeah, that was the rule. So you can
was the rule. So now it's changed.
Yes.
Okay.
That's one of the things which are, I think, required by Industry 4.0 concept, because I mean you just cannot put like this intermediate points proxies all along the way. It will complexify a lot of everything, and there is no immediate value. But there is a strong driver from the InfoSec, I mean, from security point of view, how to keep somehow, how to keep being safe. Yep.
Yeah, that's a good thing you said about security, because that's my question. Because as everyone knows, S in IoT means security. So, for example, how do you communicate with the devices? I mean, like, for example, to your company subnet or something like that. So if you gather data from the manufacturing side, how do you communicate? How do you authenticate the devices? Is there any protocol for it, like certifications or something like that?
Certificates and encryption on flight. We have different cases, a bit different story, and a bit different journey we had before in PMI, a bit different approach which we do now with AWS. We'll talk about it a bit at the end of the presentation. So about about the data flow and stuff like this.
And there will be, for example, the firmware updates also.
Sorry?
Firmware updates.
Firmware updates. OTA. No, we didn't address that challenge yet. So.
Okay. Can you answer it? Like, do you have any concepts for updating the firmware? Because you also should like check if the firmware isn't.
I understand what you are saying, because actually you can imagine that the gateways or the devices, they reside somewhere here down below, and usually the systems which manage them should be somewhere here. So yeah, we got that challenge. It's still not addressed. I mean, at least I don't have any experience in this. We do it manually.
Okay, thanks.
Yeah, so just to add to that, there are two parts to this problem, right? One, if we are talking about firmware upgrades on the machines, so those are provided by OEMs. Those are included VLANs, and very few manufacturers allow direct over the update on the machines. These are basically OEM people coming with USB stick, plugging into a machine and doing updates. And then another idea of the gateway. Gateway is the kind of bridge between these two universes, right? So you have the OT layer and you have the IT layer, and gateway kind of bridges it. Bridges are easier to manage in terms of updates because they have access to that enterprise network. So you have mechanisms to run jobs and firmware updates and do A/B testings on those. So you roll out a certain update on a certain set of devices and see if this is working, then scale it out. So that is much more standardized in that sense. So upgrades on gateways standardized, but upgrades on machine, it's still very much driven by OEM running into the machine and plugging it.
Because of the criticality reasons. I mean, there are not so many OEMs of the factory equipment which would even think about updating over the air remotely.
Yeah, I was asking because like we know the events where, for example, the atomic how it's called? Atomowa, elektrownia atomowa. Nuclear plants were publicly available, like you could change the parameters of the nuclear reactions. So that's why I'm asking about these things.
So it looks like we are more risk aware and risk, we are trying to mitigate it with not allowing, not exposing such things. I mean, at least in our company case, we don't do it. Also because of some other reasons. One of them is that you need to then perform a process which is called qualification of the equipment. So after a change, adjust the firmware, you need to still do some tests. You need to do a somehow manual test to be sure that the machine operates in a certain way. So all this process, if you would like to automate it, it will be a significant effort.
Okay.
Okay.
Good. We're good to go.
So
now the standards.
Now the standards. I kind of started speaking about this. So the idea is that why standards are important. Nobody would argue and say that standards are not important. We want to do everything in a custom manner. Everybody says standards are important because we want to have interoperability and whatnot. But the problem is that there are too many standards. If there are too many standards, none of the standards work. So how do you deal with this?
European Union. Just
make
one standard.
Make one standard. That's
well,
how
we wait for it like 6 iPhones.
And then you have Brexit.
And they change the standard later on.
So this is the problem I have every time I travel, right? So I have this European socket, and every time I go to UK and US, I need to fix this somehow. And that's the same problem that manufacturing has. So you have an assembly line, you have machines, but not all machines are built by the same OEMs. They are all built by separate OEMs, and machines don't work in isolation, right? So machines produce something, pass on to the next component, or they need to talk to our central systems. They need to speak to either to a central system to other machines. And if every machine module, if every OEM develops their own module, how do you solve this? How do you make those transitions between machines? You can solve it in the same way that you do with adapters, which is like this. So this is exactly what happens. Thankfully, when it comes to socket, there are only 5 or 6 of them, so they are standard adapters. But when it comes to manufacturing floor, there are hundreds of this. So there are no standard sockets. You have to hook them up. And this is what I see everywhere in manufacturing. So when I first came to PMI and started looking at their business problems, they showed me this 200-line parser code they have to write every time they bring in a new machine. So it's just understanding the data model of the new machine, flattening that, and make it available for the next step. So basically, they have a whole team just managing adapters and connectors. Right? And that's not just PMI. That's the case with many manufacturing customers that we see that you are. And this doesn't add any business value, right? So you are just hooking up things and connecting it. And not just that, how do you deal with these problems, right? So how do you deal with security? Because this is just custom code that somebody is writing, and sometimes he leaves the company and that code nobody touches. So it becomes a kind of legacy code. And security amount of the effort required to maintain this kind of thing, which is again not generating much business value. The main challenge that we see is how do you scale this? To make it work for one factory, how do you take the solution to 50 factories? So that's the whole scope of standardization, and that's why we started looking into what is the thing that we want to build that is transformative for the industry and can solve this problem, this core problem.
And there is a standard adapter for all the industry equipment. I mean, it has been introduced, I think it's at least in 2020, a couple years ago. So it's called OPC UA.
So yeah, OPC UA is not just another standard on top of existing 10 standard. It is the de facto open standard. And what I mean is that it's the only standard that is not proprietary for a particular OT provider or the Rockwell or automation. So this has become the global de facto standards for any kind of communications. And why is that? Because it has been around for years and the adoption initially has been very slow, but we are seeing more and more adoptions, and there are some reasons for it. Why was the adoption slow? Because it is not very easy to understand, because it compromises a lot of things and people always confuse OPC UA, why not this versus that? Because on the base layer, there is a transport protocol. So it defines the transport protocols. Like TCP, UDP, OPC UA defines a transport protocol. It defines how a module A or component A can talk to module B. So how it can send messages. So not on the content of the message, not on the semantics of the message, how they can actually just transmit, right? On top of that, it defines the architecture. So the architecture can be client server or it can be pub/sub. So OPC UA defines these two kind of architecture. It will evolve, I think, even more. For now, these two kind of architectures you can select. Pub/sub being basically publish subscribe messaging, or client server kind of request response. And on top of that, you have the base services. The base services defines the building blocks of it. So it defines how you are going to understand the semantics of the data. So it defines saying node references. So you think of like objects, and it's very similar to object-oriented programming. Like so you have objects, and under that you have objects which refer to other objects. So you have a kind of mesh of objects. OPC UA is very similar. You have call it node and references. So node and references basically is how you are the building blocks of the model. And on top of that, you have the information models. The information models are the ones that are defining the semantics of the data. It tells you what the data means. It's not just about connecting the data, but it actually tells you what the data means. And there are different kinds of information models. Some are domain specific. For example, woodworks, mining, of course. And then some of them are more around specific type of machines. You have like companion specific pumps, injection molding machines, and other kind of machines as well. And then some of them are use case specific. For example, OPC UA companion specification for machine vision, for cloud library. These are specific for a particular use case. And then some are cross-interoperability between other protocols. We have the backnet, which is cross-interoperability between other protocols. And the way I explain this is that think of this as different layers. And let's say you buy a mouse, right? So your mouse says USB 2.0 compliant or whatever. What does it mean? So you take the mouse, you plug it into your laptop, it means it works with your laptop. It gets fit into the laptop. So that's syntax of the laptop. That's the transport layer. The mouse can fit into the laptop. But the device knows what the mouse is, what it can do. For that, if you say, imagine you have to buy a mouse, every time you have to buy a mouse, you have to write a driver for it, because no manufacturer wrote a driver for a mouse. Every time you plug in the mouse, you have to define a driver for it. And that's what was happening without the information model. With the information model, basically what it does is that, okay, this is a mouse. It has 3 core functions. It has a right click, left click, and roller button, and we'll create a driver that works for all mouses. That's basically the information model. That tells you like this is a mouse, that is a core functionality, and we are defining the core functionality here. And on top of that, maybe a fancy mouse builder drives something fancy and adds more functionality. They will extend that and create that as a driver, right? That's basically the idea of vendor-specific extension. So this is the layer where you define core idea of what this thing does, whatever you are doing, whether it's a domain or a specific machine. You define this object has these kind of functionalities. If it's a pump, then okay, it will rotate and it will do certain things. And these are the attributes you can capture. And on top of that, you can refine and build a vendor specific. So that's the model, that's the idea, that's the core idea that we are working on. Can we define a kind of a universal model for the, let's say, for now, the entire tobacco industry? And PMI has been doing a lot of work on this for many years. Maybe Tom, you can talk about your experience with TSM.
It's really important to understand why we are showing OPC UA. Because it's a standard, it's an open standard, which is public. Anybody can start using it. There are libraries, documents which describe how it works. It's an open framework, so information framework. It doesn't, of course, the protocols which Ssounavuo mentioned, there are some synchronous, asynchronous one. There's the pub/sub model. You can even use MQTT with that. But it's a serious decision which you make what is the difference, which is also the difference between the IoT and IoT world. So how do you want to structure the data? What type of nodes, data nodes you will have in your model? Because for IoT, probably for the small device, just create a JSON, you put some values, key values, and voila, timestamp, you are done. But if you go in a similar way with a big industrial machine, it won't be so easy. So the way this works is to help structure not only the data nodes, but also there are some methods. So it actually says how you can call a method, how you can send a command to a machine, how it should look like, what are the types, and so on and so forth. Coming from this model, which is agnostic, there's a tobacco machine communication working group, which developed a companion specification. So actually it described what are the data types for tobacco machine.
Can I have a question here? So basically, if you use this model, it influenced on entire architectural decisions also below, right? Because it was on the left side of the slide was reference to OSI model. So I understand that everything what is below the 4 layer, it also depends how you will design that part, because it will, in my opinion, of course, this is an assumption, right? It's a kind of question. So if we will choose OPC UA stack, that it will, like create a general model of architecture, it will influence on the physical and the architecture as well.
They are definitely connected. I mean, you can imagine this is like a payload.
Yeah.
The protocols, there are a couple options, so you are somehow dependent. So if you want to use this, you have to pick up from a couple options which are...
Yeah, so it's not like, it can happen, right, that if you have already a stack that you will need to make some changes, so it's not like you will take it and it will one size fits all, right? So you will take all the devices, everything which you have right now, and just put the model on top of it and have a ride, right? So this is like completely different adventure.
Yeah, precisely right. So it works for PMI because PMI has the cloud to influence the OEMs that this is our architecture and you have to build the machine to work with that. So you have to build a machine that exposes an OPC interface. It will not work for all manufacturers. That's exactly right. So if you have the cloud to work with your end-to-end providers, and a lot of manufacturers are moving, and OEMs are also more and more seeing the benefit of doing this because they can build once and then give it to many customers, and they all work in the same way, so they don't have to custom interface. But is it there yet? Everybody is doing it? No. But for the exact reason that you pointed out.
I think I misunderstood your question. I understand it now. So because it's not also about the OSI layers, but it's about the interfaces. So actually, yes, we need to tell our providers of our machines, the OEMs, that we want to use a OPC UA, and guys, please expose the data from the machine.
Exactly, and build it the way that our, let's say, business model will able to digest it.
Yeah, exactly.
Okay, thanks.
You end up with the same picture.
You will try to translate the data from some vendor-specific like data model to this, and then you can process it with your systems.
Any questions? No questions. Let's go.
I think that I don't have anything else to say regarding TMC. It's not our this working group is not only us. It's also our tobacco manufacturers there. So there's a working group of couple big companies which agreed on how this should look like, because all of them, they know that this is really important. Yeah, how to build a post office. Before we jump into the diagrams, the reference diagrams of the IoT platform, want to talk about the capabilities of the platform. So what this platform should, in theory, do, and also a bit about why.
It looks super simple.
Yeah, I was going to say it's easy peasy.
Easy peasy. Different instances of ERP, MES, manufacturing execution systems, SCADAs, so the things which control the machines. Actually, this is the picture which I've seen when I joined our company a couple of years ago, and sometimes it's still possible. So this point-to-point connections everywhere. No event-based, forget about it. Just regular, even sometimes a lot of file-based. I love this one specifically. So you at some point you want to simplify this mess. and you want to have a global solution for all the factories, not like local ones deployed locally in different data centers, configured a bit differently with a bit different processes, creating a lot of mess, a lot of effort.
Yeah, but still, it's visible some standardization here, so it's not so bad.
I think the real diagram is 10 times more complex than this. This is all we could fit in the PowerPoint.
Yeah, but yeah, I get the point.
Yeah, just trying to visualize a bit better. I mean, if I know that this is like described as MES, but this may be different than this. It's just like a type of the system, right? Usually they are configured differently, so you cannot just transport a configuration from here to there because it will not work. You cannot create a full orchestration for this. So there are challenges on top of challenges on top of challenges. So yeah, standardization and building like maybe not unified, but a platform to cover all these capabilities is really something that a lot of people are looking for.
Just curious, what is the difference between yellow lines and the blue lines?
Yeah, the difference between the yellow lines and the blue lines.
The intention of this slide that you shouldn't understand it and not even.
You don't need to understand it. You just need to avoid that.
The idea is that this is very complex and it can mean different things. So it's not a real architecture. The point being that building architecture like an IoT platform is complex because there are so many isolated systems and point-to-point connections make it even more complex. So what we are trying to do is that centralize it as a means of simplification. And that's where OPC discussion comes in. You have one interface, you expose the data, consume the data with the same interface everywhere. And a lot of people think centralized doesn't mean that we pull in all the data from everywhere and put it in one platform. No, that's not the idea. The idea is that you are exposing one common interface to access the data. So access means whether you are building dashboard, whether you are building applications for analytics and feeding that analytics back into the system. So all the applications can be accessed from one centralized API. So centralized API again doesn't mean pull everything into one data store. It just means that there is one common interface to access the data. That's what we are trying to simplify it. So whether it's machine data, whether it's health data, whether it's a different kind of systems, everything is exposed to one common OPC standard data model. And that's basically what I'm trying to do here is kind of build the bridge into the product that we are going to talk about.
Getting there is important, and having a vision for this is also important. So this is something that we've shared with AWS, how we imagine the day in the future, how it could look like. So what you can see is like a couple points only from our North Star vision of having like this robust and nimble backbone, which I mean is something that we are looking for because currently we've built something. We have built something for last 3 years. Is it robust? Is it nimble? We build it with our own hands. We believe that together with AWS connecting our experience, their experience, we could build something a bit better. We need definitely our digital framework that's scalable, that's modular, and so on. And we need to have, like you've seen the number of the connections. So the connected ecosystems and connecting our internal and external systems through like a bit maybe better means that the point-to-point connections is something that's really must for us. And data and analytics. Currently, it takes a lot of time and effort for our customers to get a good data insights. We have some data warehouses, but creating a new dashboard, creating a new report they need, or getting access to a new data from a new sensor installed at the machine takes time. We want to improve. We need to find a better way how to do it.
This is the kind of the closest we have to something called an architecture diagram. The fundamental idea here is that we are taking the OPC information model as the first-class citizen in our service. So what does that mean? It means that if you have a source that emits OPC that can talk OPC we will discover that source, we'll find that source, we'll connect to it, we'll configure that, we'll validate that, and we'll expose the data from that source into for applications to build. So to give you an example, let's say there's a new machine in PMI. And typically in the current scenario, if you onboard a new machine, it takes what, 4 to 6 months to set up the machine? Something
3
like
to 4 months.
3 to 4 months, because there are so many steps involved. You have to set up your applications, you have to configure them, and each requires a different kind of specialty. So you have to bring that project team into the picture. They will set up the configurations, they will set up the adapter, somebody will write a parser, they will connect to the systems and make this whole work in 4 to 6 months. Just the machine lying idle, and these, believe me, these are super expensive machines, and it's just lying idle for 4 to 6 months without being used. So what we are trying to do is that because we are working with the OEMs and PMI and the end-to-end change, we can discover the machines because we know it's speaking. I'll not put those details in the slides, but I can explain it on the whiteboard. So when you bring in a machine that can talk OPC USR, there is a kind of a discovery mechanism where we can find those machines automatically without manual intervention. We'll find those machines, we'll configure those machines, set up all the applications required for the machine, start collecting data from the machine, and make the data available through an API for applications to consume. All that completely automated without touching the machine. So what we are aiming to is basically a zero-touch discovery and deployment. From what the process that took 4 to 6 months, it should be down to a matter of hours.
I want to use a very good analogy which you had before, mouse, right? Maybe some of you remember that you need to have a floppy disk with a driver, which you need to put in your PC, install the driver, go through the wizard, and then you could connect your mouse and it started to work.
I think the people in this room are too young to know about it.
No, I see there are a couple ones which may still remember that. But yeah, that's kind of a plug and play. That's kind of a plug and play. So basically, we want to have this huge industrial machine, basically have something which will detect it, and then start to get the data and will enable you to control the machine. It's really far away shot, but I think the analogy with the mouse is quite proper. So OPC UA is somehow the enabler for that, which you cannot see to the left. Edge components connected to the machine. Obviously, there are different things here. The gateway is an entity basically, but there's a lot of technology behind it. How to expose the OPC, not only expose, how to create a channel in between the user and the machine.
And when we look at the Pardur model here, so edge compute components, it's going to be a zone.
3.5.
Yeah, so it's like it's automatically divided into zones, right? Right now in this 10,000 feet view of architecture. So edge component is going to be zones, the lower zones, and the gateway, it's going to be somewhere in the middle, or you designed it how would you map it?
This gateway, I think it's not in the sense of the gateway device.
Okay, so it's like a gateway to the human interface.
Gateway to the OPC UA.
So this is the driver.
This is driver. And this component is not one big block of component. There are like different levels. So when you have a discovery, we talked about the VLAN. So there is a discovery component on each of the VLANs, which kind of helps to discover the machines on the VLAN. And then the machines basically can multicast and spread that information out to other machines that, hey, I am here. And that information needs to bubble up. That information needs to go on a gateway level, which is layer 3.5, what we call it, like the DMZ layer what you saw in the Purdue model. And then eventually it bubbles up into the cloud where we have a common source of truth, uniform source of truth. Okay, these are all my machines in the factory, in all of factories, in like 50 odd factories. I can drill down from each level. I can look at, okay, this factory is in XYZ, and there are so many machines there, and in each of the machines, you can see the status, whether they're running or not. So that drill down is possible because you can move the information layer by layer up to the top.
Right, thank you.
Any questions on the architecture? Anything that you want to discuss about?
Simplified International Space Station view of architecture. Okay, so yeah. This is the end-to-end capabilities which we identified for the Industrial IoT Platform, coming from the factory layer at the bottom, like the disconnected mode. You remember when I said about the criticality about the manufacturing process? You don't want to stop the machine because you don't have internet. That's quite obvious. Over the air, OTA updates, something that we already talked. Operational data historians, so the data which are coming from the machines, and historians, the place where we store the historical stuff. SCADA, controlling the machines, MES, manufacturing execution system. Then the industrial IoT part, connectivity, data ingestion. I don't know what it's called.
It's a lot of data.
Maybe because it's very important.
Yeah.
Because there's a lot of data.
There's a lot of data ingestion.
And even processing, because you might look at the data as a stream of, like a stream of parameters, but there are some special things like alerts and other type of events like the material consumption, which are treated not as a typical data, but kind of events. Then when the event-based architecture comes in. Data platform, asset models, industrial data, like somebody was asking about the warehouse, time series data, because the process parameters are time specific. That's why we use specific kind of databases which are better operating with that kind of data. SQL, maybe not. Connectors, so how to democratize the data. Relational databases, at the end we need them too, because we need to contextualize. We need to give a context to this time series data for some use cases. The sexy thing, AI/ML. This one is usually in PowerPoint, this one is in reality. Anomaly detection, computer vision, the two cases which we've been already talking about. And analytic capabilities. So people want to see the color graphs, lines, and so on. They want to zoom in, zoom out, see what's happening, correlate different kind of data. Dashboards and alerts. Alerts, self-explanatory. So I think that's it.
Yeah, so it might be a bit surprising that we didn't speak a lot about AWS services for the simple reason that this is kind of a reference architecture at this level. And each of this, we are evaluating what is the right service to here. But the end experience that we want to give to the user is that you can take this solution and it talks to the machine on one end and gives you a dashboard at the other end. You don't have to care whether it's running Greengrass or API gateway or like stitch together hundreds of services. It's not that. It's the service, you bring it together, you'll find your machine, connect to it, and give you a dashboard immediately. So you can see the results. That's what we are aiming for. So that's basically the end-to-end vision that we have. How we build that end-to-end vision is work in progress.
Can we also ask you something?
Sure.
Okay, guys. So during your collaboration, at which point or what kind of conflicts did you have?
What kind of?
Conflicts or problems, issues, share with us something.
Too many of them to mention.
Yeah, juicy, go for it. We need a red meat here.
I can start.
I knew that you would be the first one.
Let's
like go conflicts.
For it. I like conflicts because conflicts usually bring some value at the end usually for the both parties until you get a black eye. It's not so good. There's not so much value. But no, seriously, I think not. I would not call it a conflict, but I would call it a friction between two different realities. The reality of a modern, natively digital company, which started from it was born as a digital.
Talking about PMI, right? No, just
talking about AWS and company which exists for like really long time, and it was waterfall based. Risk, it was not, the appetite for risk was not so high. The ways of working were really, everything was really stable. So the clash of these two environments is still not easy, I believe. There is a lot of governance, a lot of rules in PMI. You really we like to control things so that things are stable. And that's our somehow mindset. It is changing, and I really appreciate it, and I see it changing, all of us. But AWS is a different story. It's a different space. It's fascinating for me how the guys are working, and we can learn a lot from them. The simple tools, really adopting Agile according to the book. So really keeping things extremely simple and moving very fast, iterating very fast. We are not used to it. Our organization sometimes is like an anchor for that. I would not call it a conflict. Definitely there's a friction. It is causing some challenges. I think it's a pain for both of us because we cannot move as fast as we could because the organization is a bit stiff. But it is also a driver for us to get better, to change our processes. So it's a big opportunity also for PMI. I don't know how it looks like from your side.
I think all of that is true, but to be honest, I think we are still in the honeymoon phase. We started in about March, April, and so far it has been going smooth. I mean, if you ask this question 1 year from down the time, probably you'll have a different answer. But yeah, so far it has been quite smooth sailing, to be honest.
Thanks. Really, really interesting question.
Wait a second. I have a question. Yeah, you will get a bag.
I don't need it. But could you go back one slide? Yeah, because I'm thinking the gateway is the point where the manufacturer connects to the cloud, yeah?
Also, this gateway term could be a bit misleading because this is basically how we are exposing the data. Think of it more as a data gateway or API gateway, whatever.
Yeah, because
this is the actual component that is getting the data from the machines and putting it into the higher layer. So that's
because I was thinking about, for example, you said about the discover, and the configuration deployment setup. So I was thinking if the agent which does discover, which does the configuration deployment, is in the cloud, or rather should be installed somewhere on the server on the manufacturer side and connected to the cloud by some networking means.
Yeah, that's a great question. I was hoping somebody asked that because that would give me an opportunity to use the whiteboard a bit. Because I'm sorry for the guys who are online, probably won't be able to see it, but
Okay, buddy.
oh, okay, okay. So OPCUA actually, are you guys all able to see it? So actually says something like a discovery protocol. So it's completely agentless. You don't have anything to. So let's say you have the machines, right? This is a new machine comes on the floor. So I need to be discovered. So if it has something like on top of it an OPCUA server, every machine that PMI at least builds or asks the OPM, they will come with an OPCUA server on top of it. Now, OPCUA has a protocol called local discovery services. So what it does is that whenever the machine starts, it will try to register itself into a certain location. So it's a configuration as a part of. If you are so OPCUA divided into multiple profiles. So if you are implementing the discovery profile, it will always try to register. Whenever machine starts, it will say like, what is my configured endpoint? I will go and register there. So it's not, you don't need an agent for that. It's just a part of the OPCUA server. So basically, there is an endpoint, and by default, it connects to localhost. So it will start immediately on its localhost, a local discovery server, and it will register itself. So what I have over here is an LDS capability. So the machine discovers and registers itself to the local discovery server. It says that I am here. This is my registry. But the universe doesn't know of it this yet. So there is no one that knows about it. What the LDS has the capability to do is a multicast. So it says that another LDS, I am here. I am here. So it sends a multicast environment. But again, there is a trick to it because these are manufacturing level 1 we are talking about. So you cannot multicast to the entire manufacturing floor. It will cause network bandwidth and outrage because everybody is trying to multicast. So this is usually limited to a particular VLAN. So beyond a VLAN, you cannot multicast. Again, this depends upon configuration and slightly different from, it depends, as you said, from different manufacturers. But the fundamental idea is that there is limitation on what you can multicast. So basically what we'll have over here is one server, which is like, this is a known endpoint. So this will get to know all other machines that are in that VLAN. So you have one good known endpoint in every VLAN. And then you have the gateway there, edge connector there. And that will start polling these different well-known endpoints. So maybe this is in another VLAN. And it will start moving the data up. So this is the gateway that we have control on. Here are components running that can do this. So then it can move the data. So we come into the machine registers itself on its LDS. It propagates within the boundary of the VLAN that I'm here. I know one good endpoint there, and that will have all information of the VLAN. I have similar one in another VLAN. From all the VLAN, I will collect this information. I push this information up where we have something called a global discovery server. So this is the common inventory of all your servers. So here you have this like a source of truth for your entire inventory. So that's basically the fundamental principle how OPC discovery works. So if you have this, all the things as a managed service, all you need to do is bring in an OPC server, connect it to your network, and this things bubbles up into your managed service.
So I got a little flashback from my networking classes, like how the internet started to work.
Correct.
But thanks for the answer.
Thank you.
I have two remarks. One is minor. So then you increase availability and you implement this service discovery and plug and play modes. Usually we affect security, and I hope that AWS specialists can handle that.
Yeah, I hope so too. I agree with you.
Because you should be aware. It's minor.
So
yeah.
When we work in teams in AWS, we have our way of working is that we define certain tenants. So tenants are like the things that helps you make decision. So a tenant is not something we'll build a great software, because building a crappy software is not an option. But tenant is something like that will help you. So one of our tenants that we have is security is job zero. So what does it mean? It means that we have a great solution that performs great and it's really working, but you have this minor security flaw that we cannot do that, because we define our tenant that security is job zero. So whatever great performance solutions your architecture will come up with, that will not work if the security is not taken care of. So security is job zero is a fundamental tenet divide across all kinds of product development that we do. So any product that we develop, if there is a security flaw, no way.
Yeah, thank you. And I agree that several years ago, it was very interesting to use IoT devices without any encryption, any security, and everybody can access it. give me an access point, please. Okay, and I have a second remark, and if we return to my first question, you've mentioned that you are afraid of vendor locking on some industrial automation solutions providers. And yes, you've solved this problem. AWS and your IT department developed some great solution, but it looks like now you have vendor lock with AWS.
That's the fundamental thing, right? So this is all the interfaces are based on OPC. So for another customer, if you can build a OPC service, it will work the same way. So the idea is that now what happens when whoever is delivering the machine, they also deliver the solutions around the machine. So you are kind of tied in. But if you can liberate that, so if you can take this application development on a higher notch, and this is talking OPC data model, I can build a application for a pump, even if I have never seen an industrial pump in my life. I know the pump companion spec. I know the data model for a companion spec, similar to the mouse example, right? So anybody can build an application for a mouse if you know the fundamental function around that is a right-click, left-click, roller button. So I can build an application that is, let's say, a digital twin of a pump. I can build this application even without understanding anything that is there, because I'm following that same companion spec and I'm speaking to the API that is a global standard, global open standard.
Before I will have one question. You said that there is multicast, right? Why are you not using unicasts in this? Because unicasts are not routable, and it's going to be easy to just limit it to one VLAN.
So this again depends on what is allowed in the manufacturing flow. A lot of places unicast is not allowed. So OPC kind of defines multicast.
So this is the OPC requirement. Okay, I'm just curious. And could you draw a line? Because what I understood that this is like a managed services, or gonna be a managed services. Where is the line when the infrastructure is, let's say, on-prem, and where is the cloud is beginning?
Yeah.
Where is happening on this diagram?
I can draw a line, but not necessarily that will be the state.
No, just for.
But you can say it is somewhere over here.
So Edge, it's still sitting, let's say, in on-prem, and then it's sending data after first part of digestion to the GDS.
To the GDS. Yeah.
That's a common definition of Edge, right?
Yeah, I'm just asking, because different, let's say, different vendors, because some of the vendors are building SDN solution about somewhere here. So you have the software-defined WAN going exactly to it over 5G. So that's why it was my question.
So that's also something PMI is kind of exploring, but it's
yeah, so Maciek stole my question a little because I wanted to ask about shared responsibility model and how does it work here? Where is the AWS responsibility and where is the, in this case, PMI responsibility?
Great question. I'm good that you are aware of the shared responsibility model because we always talk about our services. But in this case, like when you go to a manufacturer, they don't care what is deployed on the edge and what is deployed on the cloud. They want a solution that works end to end. And that is the differentiating factor of the team that I'm a part of, AWS Industries Products, versus that, let's say, an EC2 team or an S3 team. Our shared responsibility model is the entire chain. So this is what we are managing, right from the interface of the machine to the point when we are maybe even the dashboard included. So we are not
just to explain, because you are talking about AWS shared responsibility part, and PMI part is that we are connecting here and we are building something on top of it to visualize the data. For the time being, we are still developing that part. So that's how we split it. So they are responsible for the ingestion. We are responsible for the consuming.
Yes, you outsource the first layers of OSI to AWS, basically, which is good. Any questions there? Guys,
thank you very much for the questions.
Yeah.
It was really nice.
Anything on the internet? Just for a... All right, so...
don't forget about the quiz.
Σούναβο, Tómazz, thank you very much.
Thank you very much.
It was a long but very fruitful presentation. Thank you. And shout for them. Woo! Thank you, guys.
Thank you very much.
The quiz is there. So the last chances, because we will give the, let's say, some presents from PMI to the most active person, and let's vote. Who was the most active person today? It's just like, don't vote the page. You will get it. No worries, buddy. Yeah, you will get it. Come on. These questions are awesome. Thank you very much. No, I cannot take them. It's a bribe if you think of this. So thank you very much. And there are 2 more. So you get one. Yeah, of course. Come on. You ask so many questions. You don't even remember, So that's for you. Thank you very much for the time. Thanks. Thank you. And sir, you've been so interested in the bag, right? And the questions? No question, no bag. Question bag. Here we have. Thank you very much. Okay, so more pleasant part. Do you have winners, or will contact with the winners? You will contact. Maria will contact with the winners, so there are vouchers, right, for fastest answers. And guys, what to say? 60. So yeah, I can say it because I will not expose the data, private data, when I will read first part of your emails. Good. Okay, so you have them? Okay, so who in? Oh my God. Oh, you nasty guys. The email starting like this, you should be. So it's Kalafranta, 7. Karolina. It's going to be Kushinsky P. Andrei Sidorkov. And Tymaskovna Zatch. All the guys will get vouchers later on in the emails. Remember, it's AWS vouchers, not Amazon. Because we had this a little bit tense situations that we give vouchers and we cannot buy anything for them from Amazon. So AWS 61st meeting of AWS User Group KRK. It's about 10. Thank you very much again to PMI IT Hub in Krakow for supporting us for over a year. Thank you very much, guys, and see you later next year. This year we still have one.
Thank you.
Yeah, thank you very much.